You can use the distributive property to expand a product, rewriting the product as a sum. You can also reverse this process, using the distributive property to rewrite a sum of terms as a product of factors. Rewriting a product as a sum is called expanding. Rewriting a sum as a product is called factoring. In the factored form, notice that the 5 is the greatest common factor of the terms 10 times x and 45. My work here is done.
Complete the factored form of each algebraic expression.
When you are factoring, you have to make sure you pull out the greatest common factor. So in the first example, 8a plus 4, the greatest common factor between 8a and 4 is 4. Now the next thing you have to do is divide each term by the greatest common factor. So example, 8a, and we know the greatest common factor was 4, so you divide that by 4. 8a divided by 4, that is equal to 2a. So when we factor it out, we are going to put 2a here. Now the second one, we had a positive 4, so this will be 4, and 4 divided by 4 is equal to 1. So when we factor this, we are going to have 4 times the quantity 2a plus 1. Now you can check to make sure you factored it correctly by distributing it back in. So I'm going to distribute 4 times 2a, that is 8a, and then 4 times 1 is a positive 4. Now I look back here, those two are equivalent, so I know I factored that out correctly. Here's the second problem, and we have to pull out the greatest common factor in order to factor this out. So if we look here, the thing that's common between each term is m. So yes, there can actually be a variable that's considered the greatest common factor. So to figure out what's left in the parentheses, you have to make sure you divide each term by the greatest common factor. And we notice m cancels out, so we'll be left with 3 and 5/10. And here, the m's were canceled out, so I will be left with negative n. So here, all we have to do is figure out what is the greatest common factor, and that will be considered m. Here is our third example. Now remember, in order to factor out, you have to pull out the greatest common factor. And if we're looking at 14x and a positive 21, the greatest common factor would be 7. So to figure out what goes inside of the parentheses after you factored out the greatest common factor, all you have to do is divide each term by the greatest common factor. So 14x divided by 7, we know 14 divided by 7 is 2, and then you leave your variable part. 21 divided by 7, it is a positive 3. So this will be left inside of the parentheses, the 2x plus 3. And remember, you can check this by distributing back in. We know 7 times 2x is 14x, and then 7 times 3 is a positive 21. And this brings us right back to our original expression. Here is our fourth example. We have y minus xy. Now we have to figure out what the greatest common factor is. So what is common between both terms? So y is a term and negative xy is a term. What is common between those two terms? Well, I see y is common, so I'm going to pull the greatest common factor out, and that goes outside of the parentheses. And to figure what's left inside of the parentheses, remember to divide each term by the greatest common factor. So y divided by y, don't just cancel out and put nothing. Think about this. Let's say the value of y was 2. So 2 divided by 2, what does that equal? that equals 1. So instead of crossing this out with a slash and putting nothing, you actually have to put a 1 in place of it. Now I'm going to divide this by y. These y cancels out, or you can think that it equals 1. So we're left with negative x. Now you can check by distributing back in. So we have y times 1, which is y, and then y times negative x, and that will give us negative xy. So this will bring us back to our final answer, and we have to make sure we put 1 and x inside of the parentheses. Here is our last example, and we have to figure out what our greatest common factor is. So if we look at all the variables, no common variables, now we just have to look at the numbers. So what's common between 12, 16, and 10? Well, what's common is 2. So whatever the greatest common factor is, you have to remember to put that on the outside of the parentheses. And to figure out what goes inside of the parentheses, just make sure you divide each term by the greatest common factor. So what is 12a divided by 2? Well, that's 6a. And what is 16b divided by 2? That is a positive 8b. And what is negative 10c divided by 2? That is a negative 5. So you have to remember to pull out the greatest common factor, and to figure out what's left in the parentheses, you just divide each term by the greatest common factor. In order to check and see if we factored correctly, we can go ahead and extend it by distributing. So I'm going to multiply 2 times 6a, we know that is 12a, and then 2 times 8b, that is a positive 16b, and then 2 times negative 5c, that is a negative 10c. Now we have to compare it here. If it comes out to be the same, then we know we factored it correctly.
What is the factored form of this expression? Terms that have identical variable parts are like terms.
The other way around.
You can use factoring with the distributive property to add or subtract like terms. To combine these two like terms, factor out the x. So, 9 times x plus 7 times x equals 16 times x. To combine these three like terms, factor out the y. So, y plus 2 and 5/10 times y minus 3 times y equals 5/10 times y. Determine which three expressions have like terms. Drag them to the three pieces of paper. Then combine the like terms.
In order to have like terms, we must have the same variable parts. So we look at the first one. The first one is 6 minus 4p. So if we look at this 6 does not have a variable part. And this -4 has a variable part p. So this one does not have like terms because the variable parts are not the same. Let's look at this second one. N plus 6 and 25/100ths n. So these two both have the same variable part n. So this is one we can combine. The next one, 12a plus ab. Notice this 12 has the variable part a, and this ab has an additional variable part b. So these two are not like terms, so we cannot combine them. Let's look at this fourth one, 7xy minus 10xy. So the variable part for both of them is xy. So we can combine this one. This one we have -5a plus 8a. The variable parts for both is a. So we can combine that. Let's look at this last one, 2y plus 3x. What are the variable parts of each? Well, 2 has the y and 3 has the x. X and y are not the same variable, so we cannot combine those. Now let's go ahead and work on this first one. We have n plus 6 and 25/100ths n. So you can factor out the greatest common factor, which is n. And then you have to figure out, well, what's going to be left inside of the parentheses. Now we just worked on that to figure out what's left. You divide each term by the greatest common factor. And n divided by n, let's think again. Let's say the value of n is 2. 2 divided by 2 is 1. So instead of just crossing this out, we're actually going to put a 1 inside of the parentheses. And 6 and 25/100ths n divided by n, we are going to be left with a positive 6 and 25/100ths. So now we can combine what's in the parentheses. We'll have n times 1 plus 6 and 25/100ths is 7 and 25/100ths. So the final answer will be 7 and 25/100ths n. Now working on the second one, we're going to factor out the greatest common factor, which will be x, y. To figure out what's left inside of the parentheses, you're going to divide each term by the greatest common factor. 7 divided by xy is 7, and -10xy divided by xy is just -10. Now I'm going to combine what's in parentheses. 7 minus 10. Remember, this is subtracting integers. So 7 minus 10 is a -3. Now we're going to rewrite that. The final answer is -3xy. The last one, -5a plus 8, we're going to take out the greatest common factor, which is a. And to figure out what's left inside of the parentheses, remember to divide each term by the greatest common factor. -5a divided by a, it is a -5. 8a divided by a, it is a positive 8. So now I'm going to go ahead and combine my like terms. -5 plus 8 is a 3, so I'm going to rewrite that 3a. These are our final answers.
Which expression has like terms? Combine the like terms.
Excuse me, there's a new price for that. That's just gone up. Sorry, we're raising the price on that. It looks like the price just went up. Sorry.
The produce manager at the grocery store increases the price per pound of all types of fruits by 3%. Let P be the original price per pound of a type of fruit. Use this expression for the new price per pound of a type of fruit. Part A. Write an equivalent expression by combining like terms. Part B. Use the original expression and your equivalent expression to describe two ways the produce manager can find the new price per pound for a type of fruit.
Let's go ahead and get started with A. Write an equivalent expression by combining like terms. So we're going to complete this the same way we completed the other problem. We're going to pull out the greatest common factor. So let's look at these two terms. We have P plus 3/100 P. So what is the greatest common factor? Well, the greatest common factor is P. So remember, you put your greatest common factor outside of the parentheses, and to figure out what goes inside, you have to divide each term by the greatest common factor. So what is P divided by P? It is 1. And then what is 3/100 P divided by P? This cancels out, and we will technically be left with 3/100 times 1. So we are left with a positive 3/100. Now we have to go ahead and add 1 plus 3/100. We can go ahead and work that out over here. Remember, when you're adding decimals, you have to line up the decimal points. So 1 plus 3/100 is 1 3/100. So the final answer here would be 1 3/100 P. All right, now with B, it says use the original expression and your equivalent expression to describe two ways the produce manager can find the new price per pound for a type of fruit. So if we look at our original expression, it is P plus 3/100 P. So the P in this case, if we look at the problem, it represents the original price of the fruit. Now the 3/100 P, if we know what the 3/100 is, this is the 3%. We know all the fruit was marked up or increased 3%. Now the P, again, that represents the original price of the pounds of fruit. So what this is saying in words, that P is the original price per pound of fruit plus 3% of the original price. So this is what the original expression is saying. The original price plus 3% of the original price. So you have to know what the original price was. Then you have to find 3% of that. Then you have to add that back to the original price to figure out what the new price is after the increase. Now, if we look at the second expression, we have 1 3/100 P. So let's think about what 1 3/100 P is. What the 1 3/100 P represents is 103% of the original price. So you can do this two separate ways. You can know the original price. Let's actually use numbers. Let's say the original price was $10. So let's use the first equation, P plus 3/100 P. So let's say the original price is $10, so P is $10. Let's go ahead and substitute those values in. Then we have 10 plus 3% of 10 is 30 cents, or 3/10. Now we have to go ahead and add that together. So that would be $10.30. So if each pound of fruit was $10, we know it would increase to $10.30. Now let's go ahead and do this the second method. We are just going to add the percentages. So now I'm going to go ahead and substitute 10 in for P, since we said that would be the price. Now if I multiply 1 3/100 times 10, I get 10 3/10. So that lets us know it would be $10.30. So there's two different ways you can do this. You can find the 10% and then add it to the original, or you can just add the percentages and then you can multiply.
The bakery manager at the grocery store decides to have a 15% off sale on all bread. Let B be the original price of a loaf of bread. Use this expression for the new price of a loaf of bread. Write an equivalent expression by combining like terms. What does your equivalent expression tell you about how to find the new price of a loaf of bread? A clothing store advertises a sale. Your friend says that you can find the sale price of a shirt by multiplying the shirt's original price by 7/10. Do you agree? Explain.